this video, we are going to solve problems based on torsion. So first we'll discuss what is the meaning of torsion and list of formulae to solve the problems. So here in this diagram, the shaft is the member which rotates and it is supported inside a bearing. If a shaft rotates in clockwise direction, bearing will try to oppose its motion in opposite direction. So because of these two unequal torques, there is twisting of shaft, and twisting of shaft is known as torsion. And torsion is also called as torque. So the formula of torque, that is T is equal to tangential force into radius of shaft. Now let me give you the torsional equation, that is T upon IP is equal to Fs upon R is equal to G theta upon L, where capital T is the maximum torque, IP is the polar moment of inertia, Fs should be called as shear stress, capital R will be radius of shaft, G means modulus of rigidity, theta is the angle of twist, and capital L indicates length of shaft. This is the torsion equation. To understand the angle of twist, that is theta, here I consider point D on the shaft, and when twisting occurs, this point D will be shifted to another location called as D dash. And from the center of shaft, if I consider this, then here I have small angle, and this small angle would be called as theta, that is angle of twist, and this would be constant there all along the length of shaft. Here 1 degree angle of twist, that is theta, is equal to pi by 180 radian. Now let me give you two equations to solve the problems on torsion. The first torsional equation based on strength criteria, that is T upon IP is equal to Fs upon R, and torsional equation based on rigidity criteria, that is T upon IP is equal to G theta upon L. Now next formula for maximum torque, that is transmitted by solid circular shaft, where Tmax is the maximum twisting moment or maximum torque, and Fs is the permissible shear stress, and D is the diameter of shaft. And the formula for maximum torque transmitted by hollow circular shaft, where capital D is the outer diameter and small d is the inner diameter of hollow shaft. And formula for power transmitted by solid circular shaft is given by P is equal to 2 pi and T mean upon 60, where T mean is the mean torque or average torque and N is the speed in RPM. Let us solve some problems based on torsion. And here is the statement. What is the torque induced in solid circular shaft of 50 mm diameter rotating at 100 rpm if permissible shear stress is not to exceed 75 megapascal? Here permissible shear stress Fs is 75 Newton per mm square and diameter is 50 mm. Therefore maximum torque induced in solid circular shaft I'll calculate as 1840.776 kN/mm. For the next problem, the statement is find diameter of solid circular shaft if it transmit torque of 15 into 10 raised to 6 Nm, where maximum shearing stress is not to exceed 45 Newton per mm square. Here maximum torque is given in the problem and permissible shear stress Fs is 45. So I'll put the values and I'll calculate diameter as 119.29 mm. For the next problem, the statement is a solid circular shaft of 30 mm diameter is subjected to torque of 0.25 kN/meter, causing angle of twist of 3.74 degree in 2 meter length. Determine modulus of rigidity. Here maximum torque Tmax is 0.25 into 10 raised to 6 Nm and polar moment of inertia, that is IP, is pi by 32 into diameter raised to 4. The theta is 3.74 degree, which is equals to 3.74 into pi by 180 radian, and length of shaft is 2000 mm. So I'll put all the values in formula and I'll calculate modulus of rigidity will be 0.96 into 10 raised to 5 Newton per mm square. For the next problem, the statement is what length of 8 mm diameter aluminum wire so that it can be twisted through one complete revolution without exceeding shearing stress of 45 megapascal. Consider modulus of rigidity 27 gigapascal. To calculate length, I'll put values in equation Fs upon R is equal to G theta upon L. Here permissible shear stress is 45 megapascal and radius R is 8 by 2. Modulus of rigidity, that is capital G, is 27 into 10 raised to 3. And angle of twist, that is theta, is 1 revolution is equal to 2 pi. Therefore I'll calculate length 15.07 meter. For the next problem, the statement is a shaft 3 meter length and 75 mm diameter is fixed at one end and twisted at free end by force of 2 kN acting at mean radius of 0.6 meter. Find angle of twist. Assume G, that is modulus of rigidity, as 90 giganewton per meter square, which is 9 into 10 raised to 3 Newton per mm square, where T is the torque, which is equal to tangential force into radius of shaft. Here tangential force is 2 into 10 raised to 3 and radius of shaft is 0.6 into 10 raised to 3, and polar moment of inertia, that is IP, is pi by 32 into diameter raised to 4. Here capital G is 90 into 10 raised to 3 Newton per mm square and length L is 3 into 10 raised to 3 mm. Therefore I calculate angle of twist as 0.01287 radian, which is equal to 0.74 degree. For the next problem, the statement is find torque that is applied by shaft of 100 mm diameter if permissible angle of twist is 2.75 degree in length of 6 meter. Take G is equal to 80 kN per mm square. Here maximum torque we need to calculate. Therefore equation T upon IP is equal to G theta upon L, where polar moment of inertia IP is pi by 32 into d raised to 4, where d is the diameter of shaft given in the problem, that is 100 raised to 4. Here modulus of rigidity is 80 into 10 raised to 3 and angle of twist is 2.75 into pi by 180 in radian, and length is 6 into 10 raised to 3 mm. Therefore I calculate torque 6.282 kN meter. For the next problem, the statement is the shaft has to transmit 105 kW power at speed 160 rpm if shear stress is not to exceed 65 Newton per mm square, and twist in length of 3.5 meter must not exceed 1 degree. Find diameter of shaft. Take G is equal to 8 into 10 raised to 5 Newton per mm square. Here in the problem, we need to find out diameter of shaft, but to calculate diameter, first we need to have the value of torque. Therefore power is equal to 2 pi and T mean divided by 60, where T mean is the mean torque or average torque. Therefore power is 105 into 10 raised to 3, speed is 160 rpm, therefore mean torque we got as 62.66.75 Newton meter. The diameter of shaft will be find out from two equations, where first formula Tmax is equal to pi by 16 Fs into T cube. Here in problem, the relation between Tmax and Tmean is not given, hence assume Tmax is equal to Tmean, and permissible shear stress is 65. Therefore in first case, the diameter we got as 78.89 mm. For the second case, the equation is Tmax upon Ip is equal to G theta upon L. So put the values, and from second equation, the diameter of shaft we got as 112.5 mm. Therefore the required diameter satisfying the given condition is 112.5 mm, that is greater value.